Good afternoon, everyone.
Vamos aqui ter mais novo workshop, o
We
10º
have a new
workshop
workshop,
na
the
parceria
10th
da junto com a
workshop,
Usace,
in the partnership
uma
with
parceria que começou em
Osace,
2021.
a partnership that
Dessa
started
vez aqui, com
2021,
o
and this
apoio
time with the
da
support
Gabriela
of
da Usace, que está acompanhando, a
Osace
Gabriela,
team.
mais um
Gabriela is
passo
following
aqui da
us
equipe da
here.
Usace.
She's going to
E
introduce
nós
Osace a little
convidamos
bit in the beginning. Our guest,
Eric
Eric
Halpin, para
Halpin,
falar sobre a experiência
who
dos
will
Estados
talk
Unidos
about
na
the
evolução da
experience of
tomada
United
de
States
decisões
in the
nas engenharias de
decision-making, evolution
barragens.
in the base engineering,
Esses
and
workshops que a gente tem
this
com a
workshop
Usace,
that we
elas são
have with
importantes para a
Osace
troca de conhecimento
are very
acadêmico
important to exchange
com a
some
Usace
information,
junto com as
experiences with
engenharias.
us.
De
And
barragem
Osace is
junto
a
com os Estados
very
Unidos.
good
Ele
entrepreneur
tem
of dams in the United
muita
States
experiência e
and has
conhecimento
lots
para
of
compartilhar com todos nós.
experience to share with us.
A Gabi então vai falar um
Gabi
pouco agora da
will
Usace.
talk about Osace.
Gabriela,
Gabriela,
boa
good
tarde.
afternoon.
Good afternoon. Thanks, Rogerio. Thanks, everybody, for joining us here today. My name is Gabriela Livers. I'm a lead civil engineer with the U.S. Army Corps Risk Management Center. We've had a multi-year agreement with ANA where we've been working on some dam safety initiatives to better understand the risk of failures of dams in the ANA inventory and in Brazil as a whole. And it's been a really great collaborative agreement where we've had a lot of these virtual workshops. We've been working on some guidance and some capacity building. And this is our 10th webinar that we've had. It's been a series of webinars that have been very well attended, and ANA has opened up these webinars to the dam safety state agencies as well. So I think it has been a really great way to communicate part of the relationship and collaboration, like I said, that the USACE, that the Corps is doing with ANA. I think our part of our goals and objectives, like I said, has been to understand the risk of the portfolio of dams in Brazil and share with ANA how we have done that in the Corps, how our practices have changed in the last 15 years, and how, as an agency, we came to use risk-informed practices in our decision making. And today, the presenter that we have is Eric Halpin, which we consider the father of risk management for the Corps of Engineers. He was an instrumental person in implementing this change of culture in the Corps of using risk-informed practices. So I'm really excited that we get to hear Eric today. I've worked with Eric very much in the past, and I still think to this day, I don't get tired of hearing what he has to say because he is always has incredible insights into risk management for dam safety and decision making. So I welcome Eric today. And I thank him from the Corps of Engineers for participating with us in this webinar.
Obrigado, Gabriela. Muito obrigado pela parceria de
Thank you so
vocês.
much,
A Gabriela
Gabriela.
fez a disponibilidade
I'm going
do
to
Eric
thank
Halpin.
again the
A
availability of
Gabriela vai
Eric
fazer uma
Hope,
breve
and Gabriela has
apresentação
already
dele, aí
introduced
vai
him a
expor
little
o
bit
histórico que a
on the
gente
importance and the
teve
historical
no
importance he
desenvolvimento de
had
todo
in the
esse conhecimento,
development of all this
implementando
knowledge,
essa tecnologia aí na
the
Usace.
technology
O
in
Eric é
USAS.
engenheiro civil
Eric is a
profissional nos
registered
Estados Unidos, atua como construtor de
engineer,
barragens e diques,
and he's a
especializado em
builder
projetos de
of
risco e
dams,
segurança.
and
Ele se aposentou da
he's
Usace
also
tem
a
quase 40 anos,
expert in
muito
security,
produtivos,
and
como
he
a Gabriela
retired
colocou
in
aí,
Usase after
serviços
40 years. He was
considerou
very
programas
productive,
que
and he
são
generated
parte
some
da
programs
Usace
of
e também o
Usase,
Programa
and
Nacional de
also the
Segurança
national
do Diques,
program of
em âmbito nacional nos Estados Unidos. Possui
dam
diploma de
security, and
engenharia
has
aeronáutica
some
de Clemson,
uh,
em 1983,
He has a diploma on the University of Oklahoma in 1989.
Atualmente é o principal
Nowadays,
executivo da
he is the main
Halpin
executive of Halpin
Consulting LLC, onde
Consulting,
trabalha
where he
internacionalmente
works
com
internationally
clientes da
with
indústria de
the
barragens, diques e
customers
mineração.
of the mining and
Então,
the
Eric,
dam sector.
obrigado,
So,
seja
Eric,
bem-vindo.
thank you so much for your
Palavra é
presence, and you
sua.
have the floor.
Thank you. So thank you for that introduction, Rogerio. I should say boa tarde, but I apologize, the whole presentation will be in English. So this photo on the screen may be familiar to you. This is what just happened last week west of Valencia, Spain. This is the flooding they had that took them all by surprise. And so this whole presentation is about how do you make decisions in an environment where there are a lot of risk, where there's a lot of change, and there's a lot of uncertainty. So I'm going to talk about that in my presentation. So before I get there, I wanted to kind of share the context we have as civil engineers and dam safety professionals and levee safety professionals. You know, we work with owners, leaders in government, corporations that have to worry about a lot of different kinds of risk. And so this is a chart from the World Economic Forum, and it shows kind of the global risks that are going on and in a risk way, where the impact is on the vertical axis and the likelihood is on the horizontal axis. And what I've highlighted there in the middle is kind of where dams and levees fall. So I provide it as a way to emphasize that when we make decisions or recommend decisions to people who will actually invest in them, we have to understand that there's many other things going on in society, and so our decisions have to be extremely well justified and well formulated. And so that's kind of the background for the decisions themselves. Here's the agenda for my discussion today. I will talk a fair amount about the history of decision making in the US. It parallels decision making in Europe quite a bit. I'll talk about benefit cost ratios and why we really need to move away from them as an industry into a risk-informed approach. And then I'll finish up with some lessons from making decisions in a risk-informed environment. So this is just a little bit of background on me. Most of my experience comes from 40 years in the U.S. Army Corps of Engineers. The last 15 years, I was a national leader for dams and levees, where I was owner's representative for 3,000 infrastructure systems. Essentially, we changed the culture of decision-making from one that was standards-based to one that is risk-informed. I'll talk a lot about that. I was essentially a decision influencer, a decision maker, and the owner's representative. And I think many people in our field fall into one of these categories. My background is in geotechnical engineering. And so now I work with clients in industry all around the world, essentially doing the same thing, is trying to bring them to better decision making. So first, a little bit of how we got to where we are today, and it's important to understand why we did what we did and maybe why the change has actually occurred. This is one of my favorite quotes. It, you know, that dam engineering professionals, levee professionals, we work in this environment where people trust us. But sometimes that trust seems like a promise. And sometimes we've allowed the people we're trying to influence or trying to make decisions for, we've allowed that to happen in kind of a binary way, to say things are safe or unsafe, when the reality is our world is very uncertain. And it's important to understand the risk that's out there and make decisions that are risk informed and not make promises. So this is a little bit, I'll talk a little bit more about trust and where that falls into decision making. So this is a chart of dam construction in the United States by decades. And I want to talk a little bit about how this came to be. So this first period, and by the way, the World Registry of Dams has a very similar shape to their curve of when dams were built around the world. So initially, going back 100 to 200 years ago, dams in the US began to be built around this idea that it was in the national interest to build up our industries. And so roads, bridges, all of that needed water, they needed power, they needed navigation. And so dam construction, levee construction in the US started around these concepts here. Then along came World War I and World War II. There was a whole different industrial buildup to support those two worlds, the two wars. And so there was a massive buildup of dams in the US to provide power and water to the industries that were building the military industrial complex, if you will. And so big change in dam construction. The peak of dam construction was actually in the 1960s and 1970s. And this is a time when there was a peace dividend. We had just finished 2 world wars. People had better paying jobs. There was, we were not at war. And in the US, people started moving to the suburbs. And at the same time, the environmental ethics began to become a strong influence of decision makers. So I'll talk a little bit more about that. And those criteria, if you will, kind of conspired to put us in where we are now, which is not very many dams being constructed or levees being constructed anywhere in the US and really in the world. Instead, we're focusing on things like sustainability. We're focusing on risk and how to keep this infrastructure fully productive over the next century or longer. So if you track the decision making in this period, most of the infrastructure in the US was built with the concept of benefit cost ratio as a key input to decision making. That has transitioned in the US to one that is based primarily on risk. So I'll talk a little bit more about that, but another way to look at this whole timeline is right here. This is kind of each of those timelines, and I'm going to talk more about each one, but there's a couple of truths that are in here. Regardless of when we made decisions, we were not really making any bad decisions. What you see over time is an incremental improvement in the decision process. So from before 1920, it was just kind of all the decisions were about the state of the practice. Beginning in the 20s and 50s, you saw standards come in, you saw benefit cost ratio come in. 1950s and 1970s, improved benefit cost ratios. Big change in the 70s and 90s. So we were not only trying to achieve certain benefit cost ratios, but we had the additional constraints of environmental legislation, National Flood Insurance Program, and cost sharing. And those three became major constraints to decision making. And then the process of where we are today that encompasses everything that came before it, standards, benefit cost ratios, multi-criteria decision making, but it's all within the environment of risk. So risk assessment, risk management, risk communication, all of that being informed by tolerable risk guidelines. That's the TRG. So I'm going to talk about three different kinds of decisions. One is first the decision whether to act or not. So it's whether to build a new dam or not, or whether to modify an existing dam or levee or not. So that's kind of the decision to act. The second big decision is once you've decided to act, how do you act? So what guides the design decision process? So that's a method to achieve the objective. And then the last decision is really, what is the objective of the decision itself? What are you trying to achieve? What is the end state? And when do you know when you're actually achieved what you're set out to achieve? So I'll talk about each one of those for these different periods. So the pre-1920s, really not a lot of dams or levees being constructed. But what was being done was there to meet this industrialization that was happening in the US, going from a kind of a rural agricultural economy to one that's industry-based. And so the design decisions at that time are really just the state of the practice. And so you see things like global stability via methods of slices being coming onto the scene. You see Darcy working on issues of seepage and flow of water through soil. You see some people in the hydraulics and hydrology world working on flood frequency analysis, Fuller. And then also during this period, you see the initial professionalization of engineering. So American Society of Civil Engineering gets started, and the first professional engineer license, which is what I have and what is required to practice in the US, comes on board in 1907. So the project decisions were really need-based. So federal government was spending money to support the economy and industrialization. But there wasn't a strong framework around that yet. And the basis for knowing how we should build dams in this period was there was a lot of trust in the engineers. So there was trust in the professionals, trust in the state of the practice. Believe us, we understand it all. So 20s and 50s come along, and there's a lot more dams that have to be built to support the rapid military industrialization. So big jump in dam construction, levee construction. The design decisions start rapidly evolving. So you see people like Proctor, Terzaghi, Casagrande all start to influence engineering design and construction. You see the Corps of Engineers publishing many, many engineering manuals, engineering regulations, and then you see some specific technical innovations come out, like low pressure consolidation grouting on Hoover Dam. So at this time, the project decisions were influenced by law. And it was essentially the US government coming online and saying, we should invest taxpayer dollars for the improvement of flood control and navigation when the benefits exceed the cost. So this 1936 is the first time benefit cost ratios come on board. So dams and levees are being built now if the benefits that are being accrued to society exceed the cost to society. 1950s and 1970s, this is the big post-war peace dividend. People are moving to the suburbs. Dams are having to move to the suburbs with the people. And the environmental ethics is really being born here. So this is the heyday of dam and levee design and construction in the United States. The heydays, this is when most of the dams and levees are being built. A few interesting things. By 1970, 65% of all the geotechnical design criteria that we use today was already in place. The research had already been done, and that research, which today is over 50 years old, was put into place. you see our professions start to think about advancements in safety, dam safety, levee safety, and seismic. And then there was a couple really notable failures. So on the left, there's a photo of Oroville Dam in construction. It was designed and built in this time period. But also in this time period, you had the failure of Teton Dam in Idaho and Kelly Barnes Dam in Georgia. I'll talk more about that in a minute. So remember I said that the period before this, the project decisions were driven by a benefit cost ratio of greater than 1. Academia came on board. They got engaged in the whole discussion of benefit cost ratios, and they said, you know, the benefits and the cost are really uncertain. So to be sure you're making a good decision, it shouldn't just be greater than 1. The objective should be greater than 1.3. So all federal investment from this point forward is trying to achieve a benefit cost ratio greater than 1.3. This is also the time when I first got engaged with dams. So this is a photo of Jimmy Carter debating Gerald Ford in the 1976 presidential race. Of course, we just had something happen yesterday similar to this, but I was in high school and there was a dam being constructed or designed in my backyard. It was one of the last large federal projects in the U.S. And at the time, candidate Jimmy Carter was pro-environment and anti-dam. And so here he's on the debate stage debating water resource issues like this dam construction with Gerald Ford. And then on top of that, you see this excerpt from the Washington Post in 77. So I fast forwarded, Jimmy Carter is already the president. And people are complaining that this project in my backyard and in Jimmy Carter's backyard has overestimated its benefits. So it probably wasn't a justified project. And they did that on the basis of recreation benefits were overestimated. Kind of interestingly, what actually happened is we underestimated recreation benefits. The Corps of Engineers, dams provide recreation for 370 million recreators per year, more than all of the Disney parks. So it's kind of interesting that I'm debating this in high school and then I start working for them. But then in 1976, Teton Dam fails. It's a Bureau of Reclamation dam. And in 1977, Kelly Barnes Dam, and right near where Jimmy Carter grew up, it fails. And they both result in loss of life. And here's kind of the interesting takeaway from this. So this is the 70s. Same thing happened in 2005 when Hurricane Katrina hit New Orleans and 1,800 people died. In the US, federal legislation and law follows events where there's a loss of life. We've had many, many events that have cost tens of billions of dollars. They have not shaped laws about dams and levees. Loss of life has. And so at this moment, when this happened in 1977, Jimmy Carter goes on to become a pro-dam president. And he starts the first national dam safety program. The Corps of Engineers is out there inventorying and inspecting all the dams in the country. States are standing up their own state dam safety programs. So kind of ironically, Carter becomes the start of a national dam safety program in the U.S. So this next period, the 70s to the 90s, is, you know, new dam construction plummets in the United States. Most of the decisions at this time, this is where the advancements in risk are being initiated, initially by Bureau of Reclamation, then by the Corps of Engineers. States are standing up programs. You see the photo there on this slide? That's Russell Dam. That's the dam I debated in high school. I worked on it in college in construction, and then it became one of the dams I was responsible for. There's some irony in that. Designs now are just not standard space, they're hazard space. So as a profession, we're thinking about what are the worst things that can happen, the largest floods, the biggest earthquakes. Project decisions, though, are still based on this idea of benefit cost ratios, but there's three new things that happen in society. One is the National Environmental Policy Act, which says all dam and levee construction should equally consider and mitigate for the negative effects on the environment, and that it must be part of that same decision process. Two, the National Flood Insurance Program has started, which says if communities are damaged by flooding, then we will socialize that loss in the US and we will come back after the flood and give money for communities to recover. And then in 1986, Congress said, we'll also have cost sharing. So if you want a dam or a levee in your backyard, you will pay some of the cost. And so that really changed decision making. You know, these three new things were more kind of constraints on decision making. They were not objectives, they were constraints. But so the decision basis is still have a benefit cost ratio greater than 1.3, but comply with these three new things. And finally, where we are today, kind of the risk and sustainability area, very little new construction, but as far as decision making goes, Bureau of Reclamation publishes their first risk guidelines. A lot of advancements made in construction. You see the first risk-informed safety programs in the Bureau of Reclamation and the Corps of Engineers. And then you see design begin to be influenced by the concepts of risk. So during this period, benefit cost ratio is not so useful for modifications to existing dams or levees. And I'll tell you why in a minute. Everything from this point on is based on life safety and the cost effectiveness of alternatives to address life safety. And the big guide to that is tolerable risk guidelines. All right, so how did we move forward and away from benefit cost ratio? And this is kind of how decision-making evolved in the US. So the first question to ask is, how good were our decisions on new infrastructure projects? So in the US, there's $250 billion worth of dams and levees built by just the Corps of Engineers alone. And what they can show every year, they have to provide a report to Congress that says, was that investment, is it still an effective investment? And so this shows kind of the cumulative benefit cost ratio over time for those constructed dams and levees. And on average, the rate of return or the benefit to cost ratio is 8-to-1. So the decisions just from a pure economic standpoint certainly look really good. But there's some interesting things that happen. So, you know, if you work with dams or levees, the return period on the spillways and the crest elevation of levees all are designed in part based on what they are protecting in the floodplain. So it's the value of the economy below them. So that's why you see spillways and the crest of levees in the US all kind of designed around a 1 to 100 or 1 to 500 return period. The interesting thing, though, is dams are designed to be safe and not to fail when their design event is exceeded. Levees are designed to fail, so they overtop and they breach when their design event is exceeded. So you see a bifurcation, a change between dams and levees around this time based on what standards are saying about decision making. So in my 15 years leading the national programs for dams and levees, we were receiving about $1 billion a year to work on improving the safety of dams and levees. Kind of interestingly, though, that's through the normal budget process. In that same time period, we received over $40 billion after big natural disasters, big storm events, Superstorm Sandy in New York, the hurricanes in 2017 in Houston and Florida, of course, the levee failures in New Orleans. So somehow we were able to receive $40 billion after the disaster happened, but not enough of that before. So one other thing about this question of how well did BCRs work? Well, they were really effective at justifying the initial decision. For a long time, the Corps of Engineers measured safety as compliance with standards. But this is what our first risk chart looked like. So this is a risk chart of the 3,000 infrastructure systems in the Corps of Engineers. So on the chart, you see the vertical axis is the annualized probability of failure. On the horizontal axis, you see consequences. In this case, it's potential loss of life. So this is, each dot represents one dam or levee project. High risk is to the upper right. Lower risk is to the lower left. And after managing this portfolio of 3,000 dams and levees for 50 years, what we found out is 40% of them, all those above the line, had an unacceptable risk. So they were effective. Benefit cost ratio was effective at getting the projects justified and built, but they were not effective at all in managing the risk. And here's another way to think about it. Every dot on there has two factors of safety for global stability. One factor of safety for exit gradient of seepage. And all those factors of safety are the same. Yet look how different the risk is. That actually spans 7 orders of magnitude, or 1 in 10 million range. So standards really have not helped us manage risk. Benefit cost ratio really have not helped us manage risk. So this is New Orleans, 2005. The levees have failed. And what you see is the water flowing from what is the protected side where the people live back out of the protected side into the canals after the levees failed. So this is familiar to a lot of people, but the big change that happened with the levee failures in New Orleans is this right here. This may not be as familiar to you. So this is a marking done by the Federal Emergency Management Agency, FEMA, that got flooded. So in the upper quadrant here, that's the date, September 21st. The lower quadrant is the number of dead people they found in the house. So you had thousands of houses publicly marked like this in New Orleans after Hurricane Katrina. And at the end of the day, there was 1,800 people that lost their life there. And the society reacted very strongly to this. Now, there had been many huge disasters, economically devastating disasters, but this was, since the initial dam failures in the 70s, this was the first big infrastructure failure that caused loss of life. And that's really where the National Levee Safety Program came from in the US. And people began asking this question: how do we extract the country from a disaster relief environment where it's okay to spend $40 billion after the event occurred, but almost nothing before. So this was kind of the environment in which I was thrown into, and began to shape actually what we did with our dam safety and levee safety programs. So this big question we had to ask ourselves is, why is benefit cost ratio not a good metric for the built infrastructure? So when it's already built, why should you just stop using benefit cost ratio? So number one reason BCR doesn't work is when you build a dam or levee, you make a trade-off. And that trade-off is, we're going to make frequent flooding less impactful. But when the exceedance event comes along, the risk will actually be worse. And then we don't communicate that trade-off of risk with the communities. They develop further in the floodplain. And what happens is we transform the risk in the floodplain by building the infrastructure and not communicating it effectively. That's number one why BCRs don't work well. Number two is, after the infrastructure is already built, there's a greater chance of success than there is failure. And so what does that mean? So in a benefit cost ratio, if you live behind a 100-year levee or a spillway with a 100-year return period, that means over the life of your home, your biggest purchase you'll make in your life, a 30-year mortgage, you have a 26% chance of being flooded. Does that sound like a good investment? It's not. But here's why that doesn't help you in a benefit cost ratio. If you're in an area that has a 1% or 1 in 100-year level of protection, it means 99 out of 100 times it doesn't fail. You don't get flooding. And in a benefit cost ratio, you don't get to count 99% of your benefits, but you count all of your cost. So the benefit cost ratios for the built infrastructure tend to be very low, much less than 1. The third reason is, as engineers, our whole profession's been criticized. We tend to overcount benefits and underestimate cost. In fact, you've probably seen this report on the Three Gorges Dam in China. It's the same story on all mega projects. Over budget, over time, consistently. And the reasons there is risk and uncertainty isn't managed. These things are complex. There's biases, there's time pressure, changing conditions. So benefit cost ratio, when you have to look out 50 years on what the benefits will be and what the cost will be, we're just not that good at it. And this last comment is the kind of the final nail in the coffin of why you shouldn't use benefit cost ratios on existing dams and levees. And that is, benefit cost ratios ignore the concept of disproportionality. So disproportionality essentially says, well, I'll use this example to explain what it is. So that the car you see on the left is a Ford Pinto. In the 1970s, they were designed with the gas tank right near the rear bumper of the car. There was a number of highly publicized incidents where the gas tank exploded and the people in the car were burned to death. When Ford looked at this problem, they assessed it and they said, well, we still haven't gotten to a benefit cost ratio of 1. We're $11 per recall short of recalling all the cars. So we're not going to recall the cars and fix the safety issue. It's cheaper to pay the lawsuits. And so they did that. And what they found out is the public, society, believes you should overspend to avoid things that involve fatalities and disaster where people lose their life. So Ford's whole idea here is they didn't understand that you should disproportionately spend to avoid loss of life. It's another reason benefit cost ratios don't work well. So this quote by Albert Einstein is good, and he's really saying it's much more important to understand the problem than any of the skill that goes into solving that problem. Problems are harder to understand than they are to solve. So in the US, the modern infrastructure focus looks like this. Risk assessments to help you understand how things can fail and the risk associated with that. So this is the technical people, the engineers. Management using those decisions, using that outcome from a risk assessment to make decisions on what to invest in, how much to invest it, and what should be the decision objective. And then communication, so that you avoid some of the things like we just saw in Valencia, Spain, where that risk had always been there and the government agencies failed to intervene in a timely fashion, failed to let the public know risk had increased through development in the floodplain. So this is the modern focus. And if you look at it in a little more detail, it looks like this graphic on the right. So going back to what are the decisions? So project decisions are risk informed, and that's mostly coming from looking at your whole portfolio, doing potential failure mode analysis, and classifying risk on projects. Design decisions are really informed by risk. And so what's typically done in the US now is a conceptual design will be done and a risk assessment will be done on that design. And a decision to upscale the design, make it more robust, or downscale it to make it more economical would be made based on that risk. And so in this way, it addresses some things in design now that don't make a lot of sense. Why do we design dams that can have a 1 in a million? The probable maximum flood is 1 in a million, and the maximum credible earthquake is 1 in 2,000. So it kind of gives us a more rational basis to look at our standards and know when they should be strengthened or economized. And then the basis for making the decision is, are we achieving what we want? Is the risk tolerable? Have we achieved cost effectiveness? Did the design and construction achieve what we wanted? That's done through quantitative risk assessment. So that's kind of in a nutshell, where the modern era is in US. My last piece here is really just a bit of a quick discussion on, in doing this, in working, using risk to make decisions on 3,000 projects. What have we learned? And so these lessons don't just come from the US. I work in Canada, I work in Spain, Dominican Republic, India. I'm helping India do the same thing that the Corps of Engineers did. They have 6,000 large dams. So these are lessons from across, really, from the world in the use of risk. So the biggest mistake we see is that engineers have a premature understanding of the problem. They think they understand the problem and they go to solve that. And what risk does, it makes you focus and put a lot of effort into identifying the real problem. And that is through potential failure mode analysis and risk assessments on those failure modes. What we also see is the traditional deterministic world of making decisions and benefit cost ratios is there's a lot of people that start with the final answer and find problems that fit it. A lot of times outside of the risk world, the basis for the decision making is really not clear. So, I mean, if your whole decision basis is compliance with design standards, traditional design standards, you're going to get a chart like the Corps of Engineers got when it finished its first 3,000 risk assessments. You'll find out that 40% of your projects have unacceptable risk, even though they're compliant with the design standards. And then we all suffer from a lot of external pressure on schedule and milestones. And so what we've seen is the rush to implement solutions that are not well understood, sub-optimize the solutions. We end up not fixing the whole problem, and we come away from it with a bit of a false confidence about what we actually achieved. So risk kind of helps you address all of these common mistakes. So there's a lot of criticism about risk, and this is just a little bit of view into that. People are uncomfortable with the use of risk because subjectivity is a factor in risk analysis. The reality is subjectivity is a factor in the traditional deterministic factor of safety approach. Its subjectivity enters into the simplification of how the foundation is stratified, simplification of strength values within the stability analysis, simplifications within the computer models we use to actually compute the stability, doing things like ignoring three-dimensional effects. So subjectivity's always been a factor in it. What risk does, it makes you expose those subjectivities, those uncertainties, and do something about them. We've also learned that there's not one way to do risk. There's a lot of different ways: event trees, system response curves, fault trees, even descriptive methods have been effective. You can't be dogmatic about the risk model. You have to use the risk model that's appropriate for the kind of problem you're trying to understand. And then finally, you're going to support risk assessments with evidence that comes from essentially everything you've always done: numerical models, first principles of physics, theory and analysis, statistical results from empirical data, and informed judgment of experts. So all of that is part of risk. Risk doesn't operate without standards. It's just put standards in a common context. Probably the biggest thing about risk that's a lesson is understanding how dams and levees can fail and the consequences of that failure. So this is a photograph of the Challenger explosion, which was NASA was sending space shuttles to the International Space Station, and they had neglected to provide all the coordination and integration between the different disciplines. And the space shuttle failed, and it killed several people, including some civilians. So we have the same problem in our industry in dams and levees, and that is Mother Nature with water seeks to exploit our lack of coordination between all the engineering disciplines, and it does so on a continuing basis, 24/7. So potential failure modes is a creative process that kind of exposes the risk that are inherent in some of the design processes, where we design things in pieces, but they perform as systems. This is a really important one. So we live in an uncertain world. And unfortunately, as engineers, when we get pressured, we like to focus on what we know and not what we don't know. And what we know sometimes is only 10% of what we need to know. And so we go out and calculate a factor of safety to another significant digit. This is called the uncertainty paradox, that when we're faced with a lot of uncertainty, we focus on just the things we're certain about. And so one of the big lessons in risk is you have to actively think about managing uncertainty, particularly knowledge uncertainty. And the best way to do that is through science. It's rarely about getting more borings or doing higher end calculations. It's about bringing in the people in science that know how to fill those gaps of knowledge. And so, interesting thing in the US has been a big debate between geotechnical engineers and engineering geologists. Engineering geologists being able to fill the gaps through science, geotechnical engineers wanting to fill the gaps through drilling many more borings. So, when uncertain, leverage science first. Big lesson. System effects. So this is kind of an interesting thing that came out of the Oroville Dam incident. And that is, we tend to think of our dams as just single structures, but in reality, those structures are often multiple separate pieces of infrastructure, as I've kind of shown here with a typical dam in the United States. And so we use risk analysis to determine the particular interdependencies between the different infrastructure system on a single project. But it gets more complex, right? So in a watershed, you can have multiple dams and they are interacting with each other in a physical way. And that watershed is acting within larger watersheds. So there's tools to deal with this complexity. Risk analysis is the way we integrate the physical pieces of projects and how they influence each other. Things like the HEC-WAT or the HEC watershed analysis tools, how we essentially integrate the effects projects and river systems have on each other. So we have tools now to look at system effects in a more quantitative way, in a way that's better to inform decision making. Human factors. So everything I was just talking about is just down here in physical systems. The reality is, on top of that, you have governance of dam safety programs, you have human factors, people making errors, you have pressure from politics and environmental and economic and social factors, and then there's even external influences beyond that. So those systems tend to be even more complex, and the basic way we manage them and make sense of them are the dam safety programs. So they're complex, that can increase the risk. Errors and biases are real. It's really important not just to have risk analysis and risk management, but to have strong routine dam safety programs, because they deal with some of these human systems that can make things more complex. So good governance and safety programs for dams and levees mitigate most of the human factors. They mitigate most of the human errors. Big finding. So extreme events. This is also a big deal. So this is a graphic from Hurricane Harvey in 2017. That is the city of Houston. And so, we just talked about the flooding in Valencia, Spain. That was about 0.3 meters of rain in about a few hours. In 2017, Houston, Texas got almost 2 meters of rain in 2 days. And so engineers had a hard time visualizing that and talking about it, and the local newspaper in Houston published this graphic where the size of the volume of water that fell on Houston is in a geometrically accurate raindrop. So it gives a little bit of more context to the non-engineers about how much rain actually fell. Almost 2 meters in 2 days. So these extreme events are happening. They're happening all around the world. There are probabilistic methods that are really effective at dealing with them. It's really important in urban areas, cities. And what we found out in risk is we have these new methods to deal with extreme probabilities for hydrologic and seismic. But for hydrologic, the gate reliability becomes a really key factor. It can change the risk on a dam by 1,000 times, 3 orders of magnitude. So it's a really important thing to pay attention to, is gate reliability. I know these are very high level kind of lessons, if you will. Orville incident is kind of interesting. 4 big things that came out of the Orville incident. Orville is the tallest earthen embankment in North America. It's 770 feet tall or something like that. What we found out is that sometimes the no-failed branch in some event trees can transition to failure in other failure modes. So what happened is, you see a photograph here of the service spillway that began eroding, and you had stagnation pressures and slab jacking, and it began to eat away at the hillside. When that happened, they closed off the service spillway and started using the emergency spillway. And the emergency spillway was really where the risk was. That's what almost failed the dam. And so, although this failure mode did not end in failure, it caused another failure mode to be initiated, because the emergency spillway was essentially an online spillway of erodible rock. And then the other thing is, when this happened, it caused some damages due to the amount of material that went into the downstream, caused some back flooding into the powerhouse. And to avoid that, they made things worse by causing the erosion in the emergency spillway. So how damage states can play into decision making is really critical. The things we found that should be sustained, that we have to keep doing, are independent review and challenge of past assessments is critical. So the whole idea of independent experts coming to your projects to evaluate their design and construction is super critical. Then the other thing is, system issues and human factors are real contributors to risk, and they need to be part of how we assess risk. All right, so I know a couple of years ago, Brazil went down the road of starting some portfolio screening level risk assessments. I only know because we used the screening level risk assessment tool you came up with in India, but of course, we changed it quite a bit. But we appreciate having something to build off of. Screening level assessments are really important on large portfolios to understand where to start. Because if you start in the wrong location, you're not going to manage risk well. So 2 big things we learned about portfolio management are, you have to avoid type 2 errors. So type 2 errors are when you classify an unsafe dam as safe. And the reason that's a problem is that unsafe dam will then hide in your portfolio for decades, potentially. So you want no false positives. You want to make sure you have no type 2 errors. And then relative consistency ends up being really important, how you make the case for additional investment. Something else that comes out of a lesson on portfolio management is, you need to think of, like this chart, the Core's 3,000 systems. Think about different queues to manage your portfolio. And you're going to have a construction queue, design queue. The uncertain middle is going to be handled through a study queue. And then you're going to have a whole queue of nothing but dams are important to just do routine dam safety program on. So all of this, is kind of, once you get some portfolio risk results back, it's going to really change how you look at everything. It changed how and where we did research. It changed our policies. It changed our governance. It changed how we dealt with data. So kind of a final slide before we get to some Q&A. So this is a colleague of mine actually from Valencia, Spain, Dr. Ignacio Escuder. He's a professor at University of Valencia. And we wrote this paper that essentially asks the question, why are risk concepts embraced in concept, but not in practice? And so it gets to the issue of how do organizations fail when they try to implement risk, where what they say is different than what they actually believe. So that's a research paper you could search on and find. It's called Overcoming Failure in Infrastructure Risk Governance in the Journal of Risk Research. And you'll see some of the lessons I just talked about in that paper. So I appreciate your attention. Sorry it was all in English. But I think now we can maybe open up to some questions and answers.
Na verdade, o nível da sua apresentação
The
foi
level of your
muitas
presentation
reflexões, né? O
was
Brasil
like very high,
também
which brought us
passou
lots
por
of
as mesmas
reflections
coisas, mesmas
because the
etapas, como
Brazil
você
has
bem
already had
destacou
the same steps
no,
as you have
na questão do
highlighted in your
equilíbrio do termo.
presentation.
Questão de
I
análise
think
de
it's
risco no
something that is
Brasil,
in the whole, in the like in
a
the
gente
whole
tem
world,
alguns
and this
empreendimentos que já
um,
estão
risk
avançando nesse sentido,
analysis.
inclusive
There is some
para mineração
companies that
também,
have
usinas
already been
hidrelétricas,
doing this,
mas
some
é um assunto
hydroelectric
ainda
companies, but it's a
não está
matter
sendo, como você mesmo
that,
colocou, a gente não
as you said,
pontualmente
people are
algo
still
que
not
todos
putting
sabem da
into
importância, mas na
practice.
prática
Everybody knows that it's
não
very
aplicam, né?
important, but they don't apply
Inclusive, eu
it.
tive com o
So
professor
I
Scudder
I
no
was
no
with
evento do Banco
Dr.
Mundial lá
Scooter
no
in
Ceará,
a
na
in an
COGES,
event
foi
in
em dezembro,
Ceará,
foi na
which
COGES.
was for
Eles estão
the
fazendo uma
World
aplicação
Bank,
de análise de risco
and
para uma
they're
barragem, um
applying
piloto lá no estado do
risk
Ceará. Muito
analysis to a
interessante e
dam
todo o
in the
material está
Northeast.
disponível, né?
All the material is
Mas
available
assim,
on the
a
internet.
grande,
So, but
no caso, para aqui para a Ana, que tem essa
for
visão
like
mais
for Anna
nacional,
that
para
has a
Ana
more national
equivaleria os Estados
view,
Unidos, vamos
Anna,
dizer
that
mais ou menos na governança dos Estados
maybe
Unidos,
it would
mais ou
be
menos
in
o
the
que a
same,
FEMA
actually it
faz,
would be the
que é a
same
visão
as what
mais
FEMA does
geral
in the United States, which is
e
the
agência
general
reguladora, né?
vision as a
Então, assim, a gente tem
regulatory company.
o inventário americano
So
tem
we have
90
this
mil
American
barragens atualmente, hoje, 90
inventory
mil,
has
né? No Brasil, a gente
90,000
está atualmente
dams.
com
In
26
Brazil,
mil.
we
Então, a
have
análise de risco,
26,000.
a
So the
análise da carteira,
risk
do portfólio,
analysis for this
ela é o
number
que
of
está ainda,
dams
nós estamos
is
ainda
what
avançando nisso,
we are
né?
still
Para
advancing
tentar
with this
avaliar o
to try
dano
to
potencial
evaluate the
e
potential
a probabilidade de falha, né?
damage and the failure
De uma maneira
probability
macro, né?
in
De
a
uma
way,
maneira
in a
macro para
macro
todas
way.
essas
So then,
26 mil
for
barragens.
all those
E
26
a gente
dams
sabe,
that we have in
inclusive,
Brazil,
que
and
esse
we
número ainda
know
está muito
that
longe da
this number
realidade,
is still very far
né?
from reality.
Como nos Estados Unidos também o número da ordem de
As in the
90 mil,
United
né?
States, like you have
Mas assim,
90,000,
em alguns casos,
but
a
in
questão
some cases,
da, da análise de risco mais detalhada
this
para cada
more
empreendimento,
detailed risk analysis for
a gente vai ter que
every
avançar. E a
dam,
gente ainda
we
não
have
está
to
nesse
advance, and we
estágio,
are
então
not
experiências
still
de
in
vocês
this
são muito
step, in
bem-vindas.
this phase. So all your
Inclusive,
experience will be
tivemos
welcome.
recentemente, agora
We've
dia
had
24,
actually
questões também com os
we
diques de
had
proteção de Porto
some
Alegre, né? No final
protection
do ano passado,
levies
tivemos
issue
também problemas com diques.
with some levies here. We had
Final do ano
some
passado
issues
e
with
começo
that in
desse
the
ano,
end
né?
of last year, in the
Então, aqui
beginning
estão
of
surgindo
this
aqui
year.
algumas
So I
perguntas.
think there are some questions here that are
Vou,
people now are
vou então
asking.
passar aqui
So I will
colocar aqui para você, Eric.
I
Agradecer
will
novamente. E depois eu
ask the
queria falar sobre um
questions.
pouco como foi
So then I would like to understand a little bit more about the project that you've been working on in India, because India has been developing a national program for dams. They have already been in touch with Brazil and some other countries. So I imagine that India is similar to what Brazil has, but actually India has it has like a great number of dams because it's a very old country.
Se puder falar pouco
So if you can talk a little bit more about this connectivity of situations between like India, what you have seen there, and our reality here in Brazil. I don't know if you know Brazil, if you have, if Gabriela has already talked to you about it, about our country.
She has talked to me, and I've been to Brazil. I was there for iCold when I was in Brasilia. So I can talk a little bit about India. So the question is, how do you start something really big, and how do you do it effectively? So the important thing in India is we developed a screening tool, a risk screening tool, off of the Brazil model, but made it much more robust, that could be done very consistently. And then they have a very strong National Dam Safety Act, which requires the national government and the state governments to coordinate. And so they're using those legislative requirements to have all their dams, all their high hazard dams, go through the screening process. So it's a 3-tiered system. Tier 1 is screening, Tier 2 is semi-quantitative risk analysis, and Tier 3 is quantitative risk analysis. And so it's manageable once you realize screening is going to help you cut 60% of your dams and that you won't have to worry about. And then of those that you study, the 40% you study, maybe half of those become design and construction projects. So they're building a decades-long dam safety rehabilitation program, DRIP, around this concept of they're going to get to the worst first, the worst dams first, by using this screening process. So meanwhile, they have to gear up their whole engineering industry to support this. They had to gear up all their academic institutions. They now have master's classes in dam safety, master's degrees in dam safety at 2 of their big national institutes. So they're and kind of staffed up government to support all this. So they're putting everything in place, the governance, the research, the risk assessment, and they're starting with screening, and that's the key thing.
And okay, thank you very much. Obrigado, Eric. Tá falando em inglês.
Thank you.
Qual o número de barragens
What is the number of dams that you think that India has mapped in this first stage? Do you have an idea? Do you have an idea of the number?
I do. So they've done 500 dams in this Tier 1 assessments, but believe it or not, they plan on finishing all 6,000 dams by March, this coming March, because they've employed whole armies of engineers around the country to do this. And they have their top person in government. It's the Madam Secretary over their water resources, Jal Shakti government agency, who from the very top says, we'll get all of this work done.
Eric, how are they ensuring consistency with those many people doing assessments at the same time?
So that's a great question. So the national government has stood up something called the National Dam Safety Authority, and they've staffed it with a team of people that right now all they do is review screening level risk assessments. And they have a system whereby the national government can accept the risk assessment or reject it and ask for changes.
Obrigado,
turned-
Eric. Eu vou passar
Thank you.
agora
Now I will
a ler aqui algumas perguntas aqui
I'll
que
read
foram
some of the
enviadas
questions
e-mail,
here
tá,
that have
pessoal?
been
Pessoal que
sent
mandou
in the
sem
QA.
aqui e-mail, eu não vou considerar.
People who put it in the chat, I will
olha,
not take into
colega
consideration.
nossa
So
aqui, inclusive
please,
da Ana
Ana Estrava,
formação
she
na
put
área
it in
e acho que até
in
com
English,
geotecnia,
and I think she's in the
ela agradece
she's a
pela excelente palestra
geotechnician, so she
e
thanks for this.
queria saber de algumas
And
ações de
still
mitigação
wonders
para evitar
about
falsos
the
positivos,
action for
né?
mitigations in order to prevent false
Como é que
positives.
poderia,
So how,
nesses casos, né? No
in
Brasil, a
those
tendência é
cases,
nós
for
sermos
example, in Brazil,
conservadores, né?
we are more conservative. We have this
E aí, nesse
bias.
sentido,
And this,
a gente
and then
peca pelo excesso, digamos assim, né?
we kind of,
Nossa média
we
no
do too
Brasil,
much. And
50%
our average here is like
cai
50%
com
that
médio ou alto
goes
dano
with the
potencial, né? Ou seja,
average
medium
or
or
like
high hazard,
medium or high
50%
hazard,
accident.
50% of
É
the,
um percentual muito alto.
it's a very
Como
high
acho que na
number.
Índia, que você comentou,
As
Yeah.
in India that you said,
40% fica
40,
só que o nosso
40%
número
is,
é muito grande.
our number is
A
like
quantidade não é
very
500,
large. So the amount here is not
26.000,
500. Now we have
mas tudo bem,
26
só para...
them, 26,000 them. But okay, this is okay.
So there's two good questions here. So the first one is, how do we avoid false positives? How do we avoid type 2 errors? That's when you have an unsafe dam, but you mistakenly classify it as safe. So the best way to avoid that is, when you're doing risk estimates, you shouldn't be adding your conservatism into it. It should be your best idea of what can go wrong. And then when you take that numerical result and you classify the risk, you put it into a category, high, medium, low, whatever, and you're uncertain. If you're highly uncertain, you should choose the higher risk category. That keeps your attention on that project until you resolve the uncertainty. So avoiding type 2 is really about doing the best estimate, not a conservative estimate. And then when things are highly uncertain, is keeping them classified with a higher risk level. Anna, it's a very good question. So there's more to it than that. You can actually write a little policy guideline around how to avoid type 2 errors.
Ok. Obrigado, Eric.
Thank you,
Um
thank
outro
you.
colega aqui,
Another
Adrian
colleague here,
Cara,
Adrian,
pergunta aqui
he
em
asks
relação a análises de confiabilidade
regarding the
e como
reliability test
a dificuldade de
analysis
se
and how do you
calcular
determine
as
the
probabilidades de falha,
probability
né?
of failure
Para poder aplicar a análise de
in
risco,
order
né?
to apply the risk
E
analysis?
que acaba isso também sendo
Because
elemento de
then
custo, né?
it can be a
Custo.
cost element.
Yeah. So I understand the question. It depends what level, what tier risk analysis you're doing. So at the first tier, the courses level that you do on all projects, it's a very prescriptive approach based on your screening tool. It's going to guide you to be very consistent in how you come up with the probability of failure. And it's generally about, do you have these indicators of poor performance? So when you're rating the foundation of the dam, are there sinkholes? Is there seepage? Are there boils? The more of those factors you have, the more it pushes you up. In semi-quantitative and quantitative risk analysis, there's different methods to do that. I would point you to the Federal Energy Regulatory Commission guidance on dam safety. So they're a regulatory agency in the US responsible for about 2,000 dams. And their chapter 18 says, here's how you determine probability of failure. Basically, there's 4 different ways. One is to establish the key, more and less likely factors for failure and use a descriptive approach. So that's an approach that says, historically, dams in the world that have these factors tend to have a failure mode like this. The second one is to do a critical load analysis. So that's to be able to estimate through expert elicitation the probability of failure given seismic loads of different return periods, hydrologic loads of different return periods. And then the standard base is event trees and fault trees. When you're doing quantitative risk analysis, that's breaking the complex problem down to different nodes that have to happen in order for failure to occur. So that's like an event tree for internal erosion might ask you a question about what is the load probability? What is the probability of having erodible material? What's the probability of no filter on the downstream side? What's the probability of holding a roof? What's the probability of intervention? And so event trees and quantitative risk analysis can always be done on any project. No one can afford to do that on all of your projects, though. It has to be used judiciously.
Obrigado, Eric. Obrigado. Aqui tem uma outra observação, é mais comentário de
There is
colega,
another
Júlio Grilo,
comment here from Julio
observa que
Grillo,
com as
and he says that with
né,
those climate
os
changes,
critérios de projeto
the
de
criteria
microbarragens podem
for
estar
the
sofrendo
projects for dams
alterações, né, das
can
estatísticas de
be, they
probabilidade
might
de
have
cheias,
some changes,
e aí a necessidade de adaptar
and
os
then we
alertas
needed to adapt to them. So
especificamente
it's
no
just a
Brasil, as
warning
barragens
because
de
here
rejeito
in Brazil,
semineráveis,
the dams, we have
de
the
mining,
the dams
mining
for
dams,
the
né?
mining
E aí ele
residue, for
pergunta o que
example.
fazer.
And then he asks, what to do regarding those minings
Yeah.
Em casos como esse.
in cases like this?
Yeah, so there's different things you can do for climate change. The most important thing is this. Organizations that use risk for dam safety and levee safety do risk analysis on a periodic and continuing basis. So they come back and check what has changed in risk analysis every 5 to 10 years. And so then as new data is available, as new science and climate change is available, as new numerical models become available, you could begin incorporating that in. And some people may use just a generic increase in flood frequency or rain amount to capture what climate change can do. So there's different ways you can deal with that uncertain future. So one is to look at it continually. The other is to make estimates of what it is.
Obrigado, Eric. Outro colega
Thank you,
aqui,
Eric.
Rony
There is
Azevedo,
another
está fazendo
colleague here,
comentário
Rony
que
Azevedo,
tem a ver com a
and
questão da
he says
comunicação do
that
risco
it has to do with
para a
the
sociedade. Então,
communication
ele
of
fala
the
que
risk to the
a
society.
comunicação também de
And he
autoridades
says
políticas,
about
né, para
the
eles se
awareness
sensibilizarem com
of
alocação de recursos. Nós
politicians,
temos no
like
Brasil
local
também
politicians, in order to
muitas
provide the
barragens são também
resources, because
públicas, não são
many
feitas por
dams in Brazil
privados,
are
né?
public.
E essa questão da
So then I would like
sensibilização para a
to
necessidade de investir
to
na
talk about it,
manutenção e
about the
operação,
need
e também
of
essa
this
questão da
investment for
comunicação do
the
risco com a sociedade em geral.
prevention
Até
and
que
the
nível a
protection of it.
transparência das
So
informações
how
ela é
transparent
adequada a partir de que momento ela começa a
can
ser,
we be,
a ser problema, né?
and when the communication can become an issue?
Yeah. Excellent question. So typically the communication of risk, even by people that understand risk, is horrible. It's not good. In the Corps of Engineers, we had to bring in communication specialists to help us take what we knew and then talk with the public, society, about what we knew. So everyone's concerned, is risk communication going to cause panic? First answer is no, it doesn't. What people really want to know is they want to be told the truth. Then they want to know, what are you doing about it? So what are the actions you're taking? So there's a sensitivity when you talk about risk, because what you're really doing is you're saying, here's how probable we think loss of life is. Now, for 100 years, we haven't talked about it, even though that probability has always existed. So it's just our discomfort with talking about that, but there's ways to talk about it. And, you know, and standards were there to help manage risk, but they're not really effective in communicating risk. So there's agencies like the Corps of Engineers that have figured out how to be much more effective in saying, you know, compared to other dams, this dam has higher risk. These are the reasons why, and this is what we're doing about it. If you leave off those other pieces of the pie, what we're doing about it, that's when you get people that are really unhappy.
Ok, Eric.
Eric,
Hum,
can I
pode
add
falar.
one more thing? You
Yep.
know, in the last year, the Corps has made inundation maps open to the public. And the Corps has really shifted their view on how to disseminate information. And
That's a great point.
I think the Corps has really made really big strides in shifting our view that the public really can handle that information, should
Yeah.
be informed, and they will react better if they're informed.
Yeah,
And
absolutely.
yeah.
Great points. Yeah, so that whole debate about whether or not you publicly release your inundation maps happened in the US. Corps of Engineers released theirs. Other agencies like Bureau of Reclamation, Federal Energy Regulatory Commission, Tennessee Valley Authority did not. And it turns out when they were released, they don't cause panic. They don't cause home prices to drop. You know, it's just additional information people have.
Muito obrigado, Eric e Gabriela. Muito interessante,
Thank
porque
you,
o
Eric
Brasil
and Gabriela,
está numa
because
situação
Brazil
parecida, porque
is
na
in a
nossa
very
legislação, nossa lei,
is in a very similar
nós somos
situation, because our
obrigados a
act
publicar
here,
o mapa de
actually, as
inundação.
our act,
Na
we
verdade,
we
autorização de
must
emergência que inclui o mapa, né?
disclose this
E tem
mapping.
muita
It's
gente um
mandatory,
pouco
and there are many
temerosa do que
people
pode vir a acontecer
that are still afraid of doing this.
quando isso for feito, né?
Um,
Porque
when people
questão de fake
people
news, né?
communicate, because
Questão
people think that it's a fake
da
news.
questão do, mas bom saber que vocês fizeram
But
e não houve
I'm glad that you did
repercussão tão
it,
negativa,
and
né?
the people
Pelo contrário, né?
understand that it's something positive.
Bom, seguindo aqui com as perguntas,
Okay,
tô vendo
so
que o Alan
continuing
estava
here
aqui
with
nas
the
salas. Alan, se quiser
questions, Alan
aparecer,
was
será
here.
bem-vindo.
So Alan, if you
Viu?
can turn on your camera, you are welcome.
Clarice, né,
So
que gostaria de
Clarice
entender melhor o
would
conceito de
would like to
infraestrutura,
understand about the concepts of
que é uma estrutura
levees, which is a structure
ruptura em situações extremas, né?
that works for extreme events,
Que no
extreme
caso, fala aqui do caso
situations.
de Porto
For
Alegre, que em
example,
alguns
here in
pontos
Porto Alegre,
ele
there were
falhou
some
na
places that
proteção,
it
seja na questão
failed
das
in
comportas,
the
seja
protection, for like, because there was an overtopping in some places that were too low, and then somehow it enabled the flood in the city. So that's to talk. Actually, we have already talked about the levies. So in other events, we had this topic. Even the tool, like the screening tool for levies, which is interesting, but I think the thing that you mentioned between the difference between levees and the dams, the concepts of dimensions of them, the difference between them.
Do you want me to address the differences? Yes.
Yes.
Okay. Yeah. So, what's the same is the elevation of levees and the elevation of spillways in the U.S. are both formulated based on potential economic damages. So when there's more potential damages, the levees are taller and the spillways have a lower return period on them. The biggest difference is dams are designed not to fail in the extreme events. Levees are designed to fail. They overtop and fail. There's some other differences. We have a saying in the U.S. and it's we privatize the gains and socialize the loss. So when we build levees, real estate developers come in and build behind them because the land is very cheap. And then when the levee overtops and fails, all U.S. taxpayers pay for the recovery and the losses due to that failure. So we privatize the gains with builders and socialize the loss amongst taxpayers. So that's a big difference between dams and levees, is this relationship with who pays. Probably also differently is most levees in the U.S. are not owned by the federal government. They were built by the federal government, but turned over to locals to own and operate. The reality is many of them exist within river systems that have dams in them. And so the interesting thing, for instance, for Oroville Dam, the big dam in California, they had levees downstream with several 100,000 people behind them. And so they had to make releases because Oroville Dam was having a safety concern. But they could have easily overtopped those levees. So there's a relationship between who manages the risk and who is the risk imposed upon. There's a general thought that one of the big differences is dam owners can impose a risk on populations, but people that live behind levees choose a risk by living in a more risky area. So there's less of an imposed risk and more of an accepted risk. It's not completely correct, but it's a bit of a cultural mindset.
Obrigado, Eric.
Thank you, Eric. So here in Brazil, it's very interesting those things that you have mentioned, because in Brazil, our definition here for them that is in our act, it's very broad. It's flexible, but there is a possibility that levees can be considered as dams. So then we have to see the pros and cons of it, like including this, because the numbers that we are mentioning here, they are not taking into consideration the levees, only the dams, let's say that.
So in the United States, there's two laws. One is a national dam safety law and one's a national levee safety law. And in the laws, they define what a dam and a levee is. And the levee people say it's generally along the watercourse along the river, not across the river, and it's not a dam. And the dam people say it's generally across the river, but it's not a levee. So they define them what it is by what it's not. It's not the best definition. So in the US, it really struggles with the whole idea of what is a dam, what is a levee.
Ok, Eric, obrigado. E até aproveitando, uma das perguntas aqui,
Thank you. One of the
no caso
questions here
da parte de
is
mineração,
for
recebem
the
tratamento
mining
diferenciado
dams,
ou
are
elas
they
estão também
treated
na
differently
Lei
or
Nacional de
are
Barragens?
they in the same safety dam program law?
That's an
Estados
excellent
Unidos.
question. So I think in the US and pretty much everywhere in the world, the tailings dams that are associated with mining are treated separately in legislation and practice. But of course, with the failure of Brumadinho in Brazil, it opened many eyes, and now there's something called the Global Industry Standards for Tailings Management, GISTM, and that brings mining dams onto equal par with water dams. So it's all risk informed. The interesting thing behind the story of GISTM, so that they're handled from a safety perspective separately with separate regulations. But what I understand is the Church of England was a big investor in mining companies. And when Brumadinho failed, the Church of England's retirement fund was vested in mining facilities. And so it was the Church of England that actually drove the new technical standards on tailings dams, mining dams, and not government. There's some fascinating things coming out of risk and mining dams. One of them is this. There's a great study on Brumadinho, and it's different than water dams because the fluid that gets released from a tailings dam failure is a non-Newtonian fluid. So when a dam fails, most people die from drowning. When a tailings dam fails, most people die from dismemberment. They're torn apart. And so the fatality rates with tailings dams is somewhere like between 65 and 85% of the population at risk can die. Whereas with dams, it's about 1%. So the non-Newtonian fluid behind a tailings dam is very much more dangerous to people than water.
So Eric, in practice, when do you think that risk-informed decision making and risk practices will be used in tailings dams? Like you're saying, this new law has been put in place.
So it's happening right now. So what's happening is GISTM is an international standard, and it says you should be doing risk assessments. And so all around the world, you have all the engineers that typically have supported hydro dams are going over to the mining industry because the mining industry is paying more for those services. They have a lot of money. And so you see this kind of a loss of professionals from the hydro dams they're exiting and so I'm working with some of the mining companies trying to get them to establish some procedures and decision making that will work with the kind of risk assessments they're doing. So it's already started. If you're buying engineering services on the market, they cost more today because of tailings dams.
Obrigado, Eric.
Thank you,
Depois eu
Eric.
vou ouvir essas respostas com mais
Okay,
cuidado, com mais calma, porque
I will
realmente tem
read.
muita informação
Actually, I will
na
see
sua
those
apresentação,
answers
nas sugestões que você está colocando.
more
Tem
carefully
que
because they are
refletir
very,
com mais
very important, and we
profundidade
have to
na
think
aplicação
better
do caso
about it,
Brasil,
the
né?
way we apply
Tem uma
this
pergunta, eu
in
vou
our
pedir até,
country.
pessoal, estou vendo que tem muita pergunta
There
no
are
chat. Já
many
falei que no
questions
chat
in
ainda
the
não vai
chat, and I
considerar,
said
tá?
that we will not consider
Então,
the
assim,
questions that
só
are
os
in
que
the
estão
chat.
no
So only
Q&A
the ones
mesmo,
that are
eu
in
acho
the
que já vou
Q&A
considerar encerrado
session.
as
So I think
contribuições.
I
Tem
will
algumas perguntas
close
aqui ainda.
the Q&A session
E
because
agradeço a participação, mas vamos
we
lá.
don't have
Vamos ler aqui do colega da
we don't have
FIP,
much
Wigels.
time, but I will read one more. Our
E ele está
colleague
perguntando
here,
sobre o
and
DST.
he asked
Demos
about the
feito, né, na USAP.
DST,
Ele pergunta que nas últimas
and
versões do modelo
he
tiveram
said that in the
escolhas
last
dos pais, né, como
versions,
a Gabriela,
because as Gabriela
citou,
said,
nas últimas versões do modelo,
in the last
a
versions of this
modelagem é
model,
barragem a
the
barragem,
modeling,
de uma por uma, né?
it's like from one
Tendo em vista que
dam to
nós
the
temos a
other. And
possibilidade
as we have this
de ter muitas
possibility
barragens
of
no
having
Brasil e em
so
outros
many
países,
dams in Brazil and other
se,
countries,
se existe uma possibilidade
is there a
de ter uma
possibility
ferramenta que
of
consiga
having a tool that
fazer
can categorize
essa avaliação em um
dams
grupo
from an
maior
integrated
de
model,
barragens? Ou
like
como é que você
with
vê isso?
like
Se é
a
possível
larger number of
ou
dams?
não
How
esse
do you
tipo
see
de
it? Is it
abordagem?
possible to have to address this?
So I think the question is, can you do something that's more efficient than DST, right? For a lot of dams. Is that
More
true?
fast. Yes.
More fast, yeah. So
Perfect.
here's the short answer. DST is going to change engineering industry around the world. It is such a good tool. I will tell you, mining industry, hydro dams, levees, everyone is going to be using this. The fact that you can generate, well, I just saw a presentation on it at a conference, and the person doing the presentation did a live demonstration calculating that he got to inundation maps, flood flows, consequences in the space of 20 minutes. So there's not a faster way that I know of anywhere to get to really high quality data than what's in the DST right now. It is actually a fabulous tool. So for comparison, screening level risk assessments take anywhere between 4 and 8 hours to do. And it can be done by one or a couple of people. Semi-quantitative risk analysis takes multiple weeks. Quantitative risk analysis takes multiple months. DST is somewhere between screening and semi-quantitative risk analysis. But from a time perspective, it's much closer to screening level analysis, but you're getting a result that's almost equal to quantitative. So if that's not fast enough or efficient enough for you, I would say you just have a bigger problem than you realize. Because you're not going to get better or faster than that, honestly. Is that, I don't know, Gabriella, does that make sense to you?
It does, and you know, like so the last webinar that we had, we presented the LST and the DST, and we've done some case studies in Brazil of inundation mapping and evaluation of life loss, and comparing that to the information that they already had. And I think the results were really well received, and I think it provided a whole lot of information and kind of explanation as to how we evaluate consequences and to what extent we evaluate consequences. And I think right now that like especially the ANA personnel, they understand that we don't have the component yet where it evaluates the probability of failure. So that is something that we are working on right now in the core. And the idea is that we're going to use the data that we have from quantitative risk evaluations within our inventory to have failure modes that you can select from, and it gives you fragility curves to start off that would help you determine the probability of failing based on that failure mode at the location that you're evaluating. Like Eric is saying, of course, it's not going to be perfect. It's going to be more of a screening tool that then will help you make decisions on whether you need to go into a more rigorous analysis. And go ahead.
I was going to say, I think when India goes to their tier 2 analysis, they will use DST.
Mm-hmm. Well, and like Anna knows, we're getting ready to kick off a effort with Anna in evaluating what we can do to the DST to make it more applicable to international applications. So what kind of structure inventories do we have available? What kind of terrain data do we have available? Fatality rates that we should be using? How warning is disseminated in other countries? Because all of that information that is in the DST was done with documentation for the US. So we really have to look at that information critically to make sure that that is applicable to the countries that we're making it accessible to. So with our collaborative agreement with Brazil, that's kind of one of the first countries where we're actively looking at what that information is and how that information can change to make the DST more applicable to be used in Brazil.
Good answer.
Obrigado, Eric e Gabriela.
Thank you, Gabriela.
Daqui a mês, mais ou
And
menos,
then
né?
we will have our kickoff meeting in a month.
Interessante.
So very interesting.
Esperar que
Okay.
consigamos aí realmente,
So let's hope that
fazer algo que
we can
ajude nesse processo
do something that will help with this
da avaliação inicial
with
do
this
risco, né?
assessment
Preocupação aí
process, especially
Bom,
like
seguindo
regarding
com
the
as perguntas
risks.
aqui da
So continuing
colega da
here with
FEMA,
the
Fernando Sul,
questions
Carolina,
here, Carolina
ela
from the
pergunta
south,
se a avaliação
she
do
asks
risco
if the risk analysis,
tem
if it
protocolos
has
diferentes
different
dependendo do tamanho
protocols
da
depending on
barragem
the
e da
size of the
finalidade.
dam and
Se
its
existem,
purpose. If
vocês
there
existem
are
algum certo
different
padrão
kinds
em
of protocols or
relação a essa
standards
questão.
regarding the size of it.
Yeah, so the short answer is no. So risk analysis is going to look at every element of the dam and every potential way it can fail. So size and purpose doesn't enter into as much, with some exceptions. For instance, if you have a navigation dam, it has different ways it can fail than a flood control dam or a water supply dam, right? Failure of miter gates, that sort of thing. And the consequences are very different. So you might have different failure modes just based on the features, but not really based on the size. I mean, because there's it's a relatively creative and scripted approach by which you look at the different ways it can fail. And so, yeah, size doesn't matter as much. Now, you may screen a portfolio based on size because smaller dams will have lower consequences and thus probably lower risk. So some people, when they're starting out, they'll start out with only what in the US we would call the high hazard potential dams, right?
Ok, Obrigado.
Thank
Tem aqui
you.
uma pergunta que
There
ele
is
usa
another
nomenclatura
question here that he uses
no Brasil,
an abbreviation here.
agências reguladoras
Some
costumam
agencies,
pedir
regulatory
uma
agencies in
declaração de
Brazil,
estabilidade da
ask for
barragem
stability
empreendedor por certa periodicidade.
certificate for the
Ou
dams.
seja, o responsável técnico
So the the technical responsible has to sign a document making sure that the dam has a proper safety, that it has good conditions. Do you have this kind of document in the West, or how does it work, or it's not required for the dams?
So that many dam safety programs in the US and Europe require the traditional deterministic factor of safety analyses and reports. Some of the states in the US require this as part of their safety program, that, you know, a registered professional engineer signs that report. In risk practice, you're not providing a certificate of stability or a certificate of safety. You're signing the report as a professional to say, this is what we believe the risk to be. So it's kind of a little bit independent of whether or not you pass the stability issues, because in reality, we know that dams that have had a factor of safety greater than 1 for stability have failed. And we know that dams with a factor safety less than 1 have not failed. So if your whole view of safety is compliance with a analysis or certificate, you're going to miss probably your real problems.
Ok. Obrigado, Eric.
Thank you.
Acho que tenho
I
aqui
think
a Ana Estrava, nossa colega
Ana
da Ana, que em algum
Estrava
momento, acho que na sua
says,
apresentação,
so at
escreveu
a
que
point in your
às vezes
presentation,
a construção de diques
maybe the building
deveria
of
ser
of
evitada, né?
leaves
Ela
should
vem
be
com a solução,
avoided, and she
está
says,
dizendo
so
que
you're
você não
telling us do
concorda
not build
com
leaves,
esses
so you
diques,
don't
né?
agree on the building of them?
Yeah. So this is from someone who is responsible for over 2,000 levee systems in the US, their safety. And I can tell you this for sure. Anytime you build a levee, the risk only gets worse, because people will come to live behind the levee because it's no longer directly in the floodplain. And so it's a vicious cycle of building a levee, people living behind it, raising the levee, more people living behind it, and it becomes an unmanageable risk. And so the short answer is, if I were king for the day, yeah, I wouldn't build any levees.
Bom, eu acho que agradeço aí ao Eric. Eu acho que das
Thank you,
perguntas que
Eric.
tinham
I
aqui,
think all the questions were answered.
também está na
And
hora,
now we
né?
are almost
Agradecer a
we are running
paciência
out
aí
of time here,
do
so
Eric até
thank
em
you
responder
for
coisas veio fora
your
da
patience
demanda, mas
by
aproveitando
answering
muito
that didn't have
a sua
to do with
experiência
your
aí
demand, but we
no
really enjoyed
desenvolvimento
your
dos programas
experience for the
das
development
DAS.
of
E
those
agora a gente
programs. And
aproveita aí
now
pouco essa
we
expertise de vocês aí para aplicar no
used your
Brasil, né?
expertise to
Então,
apply
agradeço
here in
demais, Eric,
Brazil. So
Lopes,
I
aí
really
pela
thank
paciência e
you
esperamos manter
for
contato. E quando vier
everything,
ao
and I
Brasil,
really
por
hope that we
favor,
can get in touch.
novamente,
And please, when you come to
estamos
Brazil,
à disposição.
we will be here
E
available
agradecer
to talk
também
to
aí a
you.
equipe
And
da
thank
USAT, em
you
nome da Gabriela,
all
né?
the team
Do SEI, que infelizmente não pôde estar aqui, e outros
of
colegas.
thank Gabriela, other
E
colleagues who were not able to
esclarecer
be
que em
here.
breve essa
So I'd
gravação vai
like
estar
to
no
make
YouTube, na
clear
versão
that
português e
this
inglês. E
recording will be
lembrando
on
que
the
daqui a mais ou
YouTube in
menos
English
mês,
and
né?
Portuguese. And in a month,
Comecinho
I
de
think in
dezembro,
the beginning of
nós
December,
vamos ter um novo
we will
workshop
have
com
a new
a experiência
workshop
da
with
Califórnia na parte de
the
gestão de
experience from
incidentes de barragem,
California for the
que eles também
safety
são
management for the
agência
dams,
estadual, né?
because there is a state
Como é que eles estão
agency,
tratando com essa
and
grande
we will
quantidade
see how they are
de
dealing with
barragens que eu imagino
this
que deva ter na
number, with
Califórnia.
this
Se bem que a
amount of
Califórnia em
dams
si
that
só ela já é uma
California
ilha,
has,
né?
because California
Em
is
termos
already in
de
India.
número de
regarding the number of dams and structures, so as well as the issues.
No. So Rogerio, you're welcome, and thank you for having me. Glad to do it. To help you any way I can. Thank you, Gabriela, also.
Thanks for calling in, Eric. We appreciate it.
Yep.